Welcome to Notebook 52, Agents. In this notebook, we're going to introduce agents, which can reason about tool use and integrate the actual invocation of tools into large language model responses. By the time you complete this notebook, you'll understand the role of agents in the context of LLM tool use. You will create and utilize a simple agent capable of folding tool use results into LLM responses. And you'll also be able to integrate agents you create into LCEL chains. We'll begin, per usual, making the imports necessary for this notebook. We'll be using the request library in a API calling tool that we'll construct later in the workshop. Most of this are things that you're familiar with. The new import we'll be making is from LangGraph. We'll be importing something called Create React Agent, which we'll be looking at extensively later in the notebook. Finally, there's some printing we'll be doing using the display library. Our model instance, per usual, will be our locally hosted Llama 3.1 8 billion parameter instruct NIM. Okay, so let's talk about agents. In the previous notebook, we learned how to create tools and to use LLMs to indicate when and how to invoke tools. And then we engineered a very naive system of actually invoking tools when and how the LLM indicated that we should. This naive approach we took really lacked some key features, and perhaps the most important was that we were unable to provide the large language model, at least given how we approached the issue, with the actual result of invoking its tool, so that the LLM itself could take the tool's results and incorporate it in its response to the user. If you remember, when we used tools towards the end of the last notebook, whenever a tool use was indicated, the final output of our chain was actually the result of invoking the tool. What we would rather have is take those results, give them back to the large language model, and allow the large language model to generate a response that takes the result of the tool call into account. So to address this issue and to facilitate many more powerful capabilities, we tend to use something called agents. So the LangChain docs have what I think is an excellent description of agents. Let's go ahead and read it. By themselves, language models can't take actions, they just output text. A big use for LangChain is creating agents. Agents are systems that use an LLM as a reasoning engine to determine which actions to take and what the inputs to those actions should be. The results of those actions can then be fed back into the agent, and it determines whether more actions are needed or whether it's okay to finish. Okay, so while the topic of agents is actually a very big topic and is definitely deserving of its own deep study, we want to give some coverage to agents in this workshop and are happy to give you a chance to use them, at least in a simple fashion. Right? We have gone to great lengths and appropriately in the context of prompt engineering and application development to talk about structured output. That was a really good segue into the structured output for the sake of tool calls. And now that we understand tool calling, we really want to close the loop and give you a sensible way to use them through the use of agents. We're going to be using one kind of agent, a pre-built agent. It's quite straightforward to use. It fits in well with everything you've learned, as you'll see. But again, there's a lot more to learn about agents that we're definitely not going to be covering in this workshop. We'll talk a little bit more about additional resources for learning about agents for those of you who are interested. Okay, so it should come as no surprise that before we can think about creating an agent, we need to create tools that an agent might decide to use. So for that reason, here we're going to recreate our simple multiplication tool. This is exactly the approach we took in the previous notebook, where we use a Pydantic class to articulate the arg schema. We decorate a Python literal function with the tool decorator providing the arg schema. And just to demonstrate, we can invoke this tool and we can create a collection of tools, which in this case has only a single tool, but we'll declare variable tools to store any tools that we might create. Okay, so to create an agent capable of utilizing tools when appropriate and furthermore integrating the results of a tool call into its response, we're going to use a library called LangGraph. As you know, we've been using LangChain throughout this entire course. LangGraph is in fact a spin-off open source project from the same folks who created LangGraph. And at a high level, LangGraph promotes the easy creation of graph-based workflows. That's the name LangGraph. If you're unfamiliar with computational graphs, we can say that graphs are a collection of nodes which are each responsible for doing some sort of computational work, and edges. And edges are mappings between nodes and define when and how nodes will be invoked to perform work, right? So we're going to limit our work with LangGraph in this notebook and in this workshop to using a simple yet powerful pre-built agent that ships with LangGraph. But if you find yourself wanting to learn more about agent creation, we highly recommend taking the time to learn more about it at LangGraph. At the current time for me, the DLI is also creating workshops on agent creation and multi-turn agent creation. And I believe that the LangGraph community is also putting together a lot more in the form of tutorials, instructions, examples, etc. On agent creation. So again, we're going to keep it simple here, even though there's a lot you can get out of what we're doing in this notebook. But for those of you who want to learn more about agents, there's a lot of resources at your disposal. Okay, so as we mentioned, agent creation is a large topic worthy of its own coverage. However, LangGraph ships with some pre-built graphs that are very easy to use, and we're going to leverage one of them in this workshop, namely a React agent graph. So REACT stands for Reason and Act. This term was articulated in a paper that you can read here if you're interested. For this workshop, we can think about the REACT paradigm as a way of instructing an LLM to reason about whether or not it should use an external tool or tools, and then when appropriate, utilize these tools before generating a final response, right? It reasons about what needs to happen and it takes actions. With LangGraph, to create a React agent, we can simply import the create React agent function. You saw this above. We'll show it again here. It's off of langgraph.prebuilt. It's called create React agent. And it's a function, and all we have to do is pass it an LLM instance, which we've already defined above, and a named argument, which should be a list of tools, which we only have a single tool right now in our tools variable, the multiply tool, but we'll provide that here as well. Just as a minor point, it's worth mentioning that we have not used bind tools, right? This is not an LLM with bound tools. Rather, create React agent expects a, let's call it vanilla LLM instance, and then a named argument tools containing any list of tools that we want to make available to our LLM. So our agent now, right, we've defined this as agent, has a helper method, and this is where we're using our display function to help us see this computational graph that we were talking about. So as mentioned above, the graph consists of nodes, which you can see by these ovals and rectangles, and they are capable of performing work. And then in between the nodes are edges, which have some names, but are also indicated by a variety of different kinds of lines with arrows. And they describe how data ought to be passed between nodes in order to accomplish work. So in the above image here, we can see that at the start of the graph, incoming data, which we can think about primarily as a prompt, will be routed to the agent, which in our case is our LM instance, and under the hood by LangGraph has been prompted to reason about whether or not to utilize any tools that we provided the agent. Depending on whether or not the LLM believes a tool should be utilized, the agent will either continue on to the tools node, where an appropriate tool will be invoked, and then return the result of calling that tool back to the agent node. Now, something that's different than what we did in our naive approach in the last notebook is that sometimes multiple tools need to be used, or a tool needs to be used more than once. So in this case, the agent can continue sending information to the tools node as many times as it deems necessary until it arrives at a state where it has completed all necessary tool calls. And then at that point in time, or if no tool calls were ever needed to begin with, then the agent will follow this edge here and send the final response back to the user. Okay. So invoking our agent, which again we have already created here, has a lot of similarities to invoking LangChain chains, but has a little bit of opinionated structure that we need to adhere to. So we're going to talk about that here. So LangGraph graphs, like the one we just saw a visualization of, are stateful, which means that there is some sort of data structure, usually a dictionary, that contains all the information that any given node might want to read from or write to. And in the case of the pre-built Create React Agent graph we're using here, the graph state is already created for us under the hood. And the only value that the state has is a messages key, which is a Python list of messages. So what this means for us kind of practically is that when we use the agent graph, we need to add our human message prompt to its state, right? And namely, we need to add it to the messages property of a dictionary. And furthermore, we can expect that any other activities such as AI messages, right, model responses in the graph are also going to be added to the same messages property. So that's going to be the one key difference we need to manage when working with our agent instance here. Just like in LangChain chains, our LangGraph agent has invoke, batch, and stream methods on it. Okay. So, to begin, let's use the invoke method on the agent graph using a simple prompt, and one where we would not expect the agent to believe it requires the use of the multiply tool we've provided. The return value of invoking the graph will be the state of the agent graph after it completes, which we'll store in a variable for further exploration below. Okay, so here we're going to invoke our agent just as if we would have invoked an LLM instance, but as discussed, this particular form of agent, instead of it expects all new messages, including prompts, which we're prompting here, it expects them to be added to a messages property, which contains a list of strings, right? And there's some things going on under the hood here, but basically what we can assume is that we need to provide a list with our prompt and apply that to a messages key of a dictionary when we invoke our agent. So we'll go ahead and invoke that. Agent state, which we've captured here, will be the current state of the graph.